Hello everyone. We will learn the programming language of PLC in this lesson. We will explain and analyze mainly from three aspects: introduction to PLC ladder diagram, specific usage methods of PLC ladder diagram, and other programming languages. We humans communicate through language, and we communicate with people from different countries in various languages such as Chinese, English, French, etc. Therefore, if we want to communicate with machines, we certainly need to understand their language, such as the PLC language we are going to learn today. What we need to learn is the most commonly used language in PLC ladder diagram. Ladder diagram is a graphical programming language that represents the logical relationships of circuits in the form of a ladder diagram to achieve industrial control. The ladder diagram mainly consists of two parts: input and output. The input part refers to the input conditions and the output part refers to the output results. In a trapezoidal diagram, it expresses the output results under what input conditions. The trapezoidal diagram expresses the logic in this way. Let's observe the picture. The figure shows a ladder program where the input part refers to the contacts and the contacts represent the input conditions. There are two forms of input contacts in the ladder diagram. The one on the left refers to the normally open contact, while the one on the right is the normally closed contact. After the PLC scans the input contact, it accesses the memory bit specified by the contact operation number. The data in this bit changes from 0 to 1, and the corresponding normally open contact is connected and the normally closed contact is disconnected. For the input contact, the PLC performs a read operation, so the number of contact uses is not limited in the user program. The output part refers to the coil, which represents the output result. The output coil receives the logical operation results of the input contacts and sends the results to the coil to perform corresponding actions. For the output coil, the PLC performs write operations. In the analysis of traditional relay control circuits, the main focus is on the on-off of contacts and whether the coil is powered on. In fact, in the ladder diagram, we still observe this transmission situation. The line on the left side of the ladder diagram is called the bus, and there is conceptual energy on the bus. The flow of energy flows from the bus from the left to the right, usually represented by signals. On the ladder diagram, we observe the transmission of signals and whether the signals have arrived to determine the program execution status. It should be noted that when writing a program, the same coil can only appear once. The PLC adopts a scanning cycle from top to bottom and from left to right. If there are two identical coils in a program, according to the working mode of the PLC, even if the input contacts on top are connected, the output coils on the back will not be connected because we know that the scanning of the PLC is from top to bottom. So when scanning the first line, the coil is connected, but in the second line, the input contact is disconnected and the PLC will disconnect the output coil covering the previously connected coil state. Therefore, the PLC's output coil state is disconnected. When writing a program, we should pay attention that a coil cannot appear multiple times in the program, otherwise it will cause errors in the program. When we use TIA software, all instructions can be changed to other similar instructions where they are displayed. When using this function, the software will automatically list other similar instructions together for users to choose from as shown in the figure. First, move the mouse and click to select M0.1. Then, double-click the left mouse button to pop up a drop-down list which displays all available commands for selection. The PLC ladder diagram uses graphical symbols to represent logic and control functions and uses trapezoidal shapes to represent program flow capable of controlling machine operation, monitoring process parameters, and collecting data. The PLC ladder diagram is composed of different symbols and circuits. These symbols represent different logical components such as contactors, circuit switches, timers, and counters. These components form complex logical expressions that integrate the input and output of the device, enabling them to interact with the control system. In the input phase, the PLC collects external input signals as the basis for program operation. Then, during the program execution phase, the PLC executes each functional module in the order of the ladder program. During program execution, the PLC continuously updates the internal status and register values for subsequent logical judgment. In the output stage, the PLC changes the state of the output signal to a preset value and sends control signals to external devices to control the industrial automation system to achieve the preset functions. Overall, a PLC ladder diagram is a logical circuit diagram represented by graphical symbols, which controls industrial automation systems by scanning and executing programs. In addition to ladder diagrams, we can also have a brief understanding of other programming languages. PLC language. Statement table. Statement table is composed of mnemonics and operands. A statement table is a program consisting of a number of statements. A statement is the smallest independent unit of a program. Structured text. Structured text is called SCL in the Siemens programming language. The SCL language allows the direct creation of SCL language blocks. The SCL language is also edited in a text-only environment. Sequence function chart, known as S7 graph in Siemens programming software. It is a programming language for sequential control systems. In a PLC-designed program, many user programs control jobs that require the machine to follow a certain process step by step. Function block diagram, known as FBD in Siemens programming software. Function block diagrams use a programming language similar to that of logic gates. Function block diagram instructions consist of input variables, output variables, and logic functions. Finally, let's take some exercise. That's all, thank you.